So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics, and I'm Aman, just welcoming you all to my new amazing video in which we are just going to prove or expand these four things with Euler's formula. And as you might have noticed in the thumbnail, even right. So, yeah, and you know what? Like, you might have used this thing in your life earlier, sine of 2 theta, or maybe sine of 2a, right? And what that says is 2 sine of a times cosine of a. You know what? This is just the application of our very first thing that we are going to prove today. So just imagine that if you're going to prove this one, this one, this one, and even this one, so that's really gonna helpful for us. And let me tell you, i have never saw I have never seen like any teacher or any professor that proved this thing. So I think it's quite needed because we don't need to just memorize it. Okay. And yeah, our main path would be e to the I theta equals cosine of theta plus I sine theta. And yeah, I have uploaded the proof of this thing that is known as Euler's formula. So you can just check that out, check that video out. I have uploaded this on my YouTube channel. That is okay. So I think we should begin because it's gonna quite taking a lot of time. But yeah, so basically we are just going to use this thing, right? So yeah, let's just move on to our proof. So firstly we will just go with sine of a plus b, right? So I'm just going to use this formula for instant. So I'm just going to replace this formula with a plus b. So theta is a plus b, so it becomes e to the I times a plus b comes out to be, when you replace it with that, so that's gonna cosine of a plus b plus I times sine of a plus b. Okay, so far so good. And I'm just going to just uh, catch it in a bracket. And again, I'm just going to use this further. So I'm just going to use this as, I'm just going to break it something like this: e to the ia times e to the ib. And what that gonna give me, that gonna give us, well, this step is really mesmerizing, just believe me. uh Look at this one. So if you relate this with this one, so theta is a, so just replace theta here with a and just play with that here. So that's gonna give us, let me just change the color, I think. So that's gonna give us cosine of a plus I times sine of a. How cool is that? And times, if we talk about b part, that is this one, so that's gonna give us the same with the argument becomes b. So this is what we are having, right? Okay. And now let's just multiply these two parentheses with each other. So that's gonna give us cosine of a times cosine of b, and that's gonna give us plus I times sine of b cosine of a plus I times sine of a cosine of b, and plus I square times sine of a sine of b. How cool is that, guys? Like literally just have a look at this. And now as we know that I squared is -1, so just replace it with -1 here. So that's gonna give us cosine of a cosine of b, and plus let me take I common from these two stuffs. So that's gonna give us I outside sine of a cosine of b plus cosine of a sine of b, right? And when you plug I squared equals -1 here, so that's going to give us minus of sine a sine b. And now you can see that we can take something here, that is, I'm talking about this one. So that's going to give us cosine of a cosine of b minus sine of a sine of b, and plus I times sine of a cosine of b and plus cosine of a sine of b. Okay, So from here, like what we evaluated so far is e to the I a times e to the I b, and that eventually becomes e to the I a plus b. So from this part, like from this one, we can compare the imaginary part with the imaginary part of this one, right? So if you compare it with that, so that's finally gonna give us sine of a plus b equals sine of a cosine of b plus cosine of a sine of b. Hence proved. The first part is being proven successfully, right? And this is how, isn't it amazing, guys? Just tell me, like I just want to know that how did you feel about this, and how do you feel about this, right? Because this is really amazing, I think. Okay, and if we compare the real part, so that's gonna give us cosine of a plus b, a plus b equals cosine of a cosine of b minus sine of a sine of b. Again, the very it's also among those things which are really important in trigonometry. So yeah, these two things have been proved, and now we're looking for the negative, like just replace here with negative, so we're looking for that, right? And let's use again the Euler's formula to prove that even. So now, okay, so let me just change the page. So yeah, so I'm looking for sine of a minus b and cosine of a minus b using the Euler's, sorry, not reflection actually, Euler's formula. Cosine of theta plus I sine of theta, just theta replace a minus b with, so that's gonna give us e to the I of a minus b comes out to be cosine of a minus b plus I times sine of a minus b, right? So this let's assume this as our first equation, right, as we did in the previous evaluation, right, proof. And now if we talk about this one, so that's gonna give us e to the ia times e to the minus ib, I'm sorry about that. So that's gonna give us cosine of a plus I times sine of I'm sorry about that, sine of a and times cosine of minus b plus I times sine of minus b. And please just be careful that, let me just tell you right over here, that sine of minus theta is minus sine of theta, and cosine of minus theta is just cosine theta, just so yeah, this is what we are going to here going to use here. So when you just multiply this parentheses, so that's gonna give us e to the I of a minus b, and that's gonna give us cosine of a cosine of b, and when you just solve the I term, so that's eventually becomes or let me just do it step by steps, right, step by step actually. So that's gonna give us I time I of sine a cosine b, right, and then plus I, oh I'm sorry, not plus, minus I times sine of b cosine of a, right, and minus I squared sine of a sine of b. When you solve I square, so that's gonna give us -1. So yeah, okay. And oh wait a second, yeah, okay. So e to the I times a minus b, that's gonna give us cosine of a times cosine of b, and plus, look, this becomes plus, right, sine of a sine of b, and plus when you take I common here, so that's gonna give us sine of a cosine of b minus sine of b cosine of a. And now again you can compare it with that, so that's gonna give us sine of a minus b comes out to be sine of a cosine of b minus sine of b cosine of a, and when you compare cosine of a minus b, that's gonna give us cosine of a cosine of b plus sine of a sine of b. How cool is that? And let's just prove the sine 2 angle, like this one I'm talking about. Sine 2 theta equals 2 sine theta cosine theta. Well, we just have proved, oh, let me just write it down as sine theta plus theta. So we just have proved here. Let me just show you here. So yeah, when you replace theta, so that's gonna give us sine theta cos theta, sine theta cos theta, and so for the next term sine theta cos theta, and when you just add them up together, so that's going to give us 2 sine theta cos theta, hence proved. So yeah, this is really amazing. I was thinking to prove this one in front of you, but then I thought to just prove it from base. So this is the base. So yeah, this was it. It was all about this thing. And yeah, if you learned something from here, thank you so much. And please consider liking the video, and if you subscribe it, so you're gonna get a lot of things from me, believe me, and I will never leave your hand. So yeah, thank you for watching this video. I love you guys. Goodbye, take care.